Hi, today we'll discuss the cross multiplication algorithm, which is very useful. I will give you the statement of the cross multiplication algorithm and we will also discuss the proof. So let's read what I've written on the board. Suppose A, B, C, D are whole numbers and B is not equal to 0 and D is not equal to 0. Then this statement A over B equals C over D is equivalent to A times D equals B times C. So what we're saying here is, first of all, look at the symbol. This symbol means equivalent to. And what the statement tells you is, anytime you encounter this kind of an equation, a fraction equals a fraction, A over B equals C over D, then we can replace that equation by an equivalent equation which conveys the same information. And notice how we get this equation. We cross multiply, then we get AD, and we are saying if you cross multiply like this, BC, those two quantities are going to be equal, and you can write this equation down. So we are saying anytime you have this equation, you can replace it by this. And anytime you have this equation, we can replace it by this equation. So that's what the cross multiplication algorithm is telling you. It's a very useful algorithm, and to prove it, what we'll do is first we'll assume this statement is true, A over B equals C over D, and then we will show that statement implies that this statement is true. So from there we'll try to arrive at this equation. And for the part B, we'll assume this part, AD equals BC is true, and then we'll show that if that is true, then this equation must be true. That's how we're going to proceed in the proof. But before I start the proof, let's kind of get a feel for this cross multiplication algorithm with numbers and see how that might work out. So here we are given A over B equals C over D, two fractions that are equal. So you know that happens when we pick equivalent fractions. So let's pick 2 over 3 for our A over B, and pick another equivalent fraction of 2 over 3. So let's just write 4 over 6. So as you can see, 2 over 3 equals 4 over 6. We believe that that's a correct statement. And what the cross multiplication algorithm is saying is, if you were to multiply this way and get a cross product, so 2 times 6, that's 12. We claim that 12 is also same as this cross product. If you multiply these two guys, 3 times 4, 12. We believe that. So we can see for this example, the cross multiplication holds true in this direction. If this is true, then we can see these two cross products are equal. And similarly, if you would like to get a feel for the other side, let's pick two numbers for A and D. Let's pick 2 times 3. That's 6. Now we need two numbers whose product is also 6. So let's pick 6 times 1. This statement we all agree is 2. 2 times 3 is 6. 6 times 1 is true. The cross multiplication algorithm is telling you, if you regard this as D and this 6 as B, cross multiplication is telling you, if you were to do 2 over 6 A over B, and if you were to do C over D, 1 over 3, cross multiplication algorithm is telling you these guys are going to be same, and we can see they indeed are. 1 over 3 and 2 over 6 are equivalent fractions. So we've just checked that this cross multiplication is true for some chosen numbers. Now we're going to supply a proof that will hold true for any numbers. So let's move on and work with part A of the proof right now. So let's prove this. We're going to assume that A, B, C, D are whole numbers and these denominators are not 0, and we're going to assume A over B equals C over D. Starting with that equation, we will arrive at this equation. So let's write, assume that A over B equals C over D is given. That's a correct statement. Now, as you know, by fundamental fact about equivalent fractions, we may multiply the numerator and denominator of any fraction by a non-zero whole number. So what I'm going to do now is, by f of EF, we can write this equation as follows. I'll put the equality sign, and I will choose to multiply the top and bottom of this number by the whole number d, which we know is non-zero. So that would be AD over BD. And on this side, I will choose to multiply the top and bottom of this fraction by B. So that will give me BC over BD. So we've applied fundamental fact about equivalent fraction 2 times to arrive at this equation, starting with this equation. Now let's look at this equation and see what it says. AD over BD, that is, another way of saying it is AD copies of 1 over BD. That's the language we learned when we discussed fractions. That is equal to BC copies of 1 over BD. So notice we are looking at the same thing, 1 over BD, 1 over BD. And we are saying AD number of copies of that same thing is same as BC number of BC copies of that exact same thing. From this, we can conclude that AD equals BC. Hence, AD equals BC. And so this proves part A. So what have we done here? We've started with this equation and we used logic, namely fundamental fact about equivalent fractions 2 times, to rewrite this equation or to replace this equation by another equation, equivalent equation. And then we interpreted this equation to mean this sentence, AD copies of 1 over BD is BC copies of 1 over D. From there we used logic to say, well then AD would have to be BC. AD would have to be BC. Anytime you see this equation, A over B equals C over D, you can feel free to replace it by this equation. And how do you get this equation? Cross multiply. AD, that's this side, equals cross multiply, that cross product BC goes on that side. So keep that in mind, and then we'll move on and prove part B right now. So for part B, we assume that we're given whole numbers A, B, C, D such that A times D equals B times C. And now we're going to prove that in that situation, A over B must equal C over D. So here's how we proceed. Okay. Assume AD equals BC. And now what we do is we divide both sides by BD. B, remember, B is non-zero, D is non-zero, so BD is non-zero, and we can do that. Then if you do divide both sides of the equation by BD, then this is what we get. AD over BD equals BC over BD. And now we can apply the cancellation law. To get the following. Note here, this is A times D over B times D. D is a common factor of both the numerator and denominator. So if you apply cancellation law, we get A over B. And similarly out here, we have B times C over B times D. B is a common factor of both the numerator and denominator. Apply the cancellation law again, then we get C over D. There it is, A over B equals C over D. So now this proves part B. So let's go back and look at the cross multiplication theorem one more time. So here's the statement of the cross multiplication algorithm. You want to remember the cross multiplication algorithm by its name and what it says, so that anytime you see this kind of an equation, you can, in the next step, simply say by cross multiplication, do the cross products and equate them. AD is sometimes called a cross product because you're multiplying across like this. BC is another cross product. Those cross products are equal. And conversely, anytime you see an equation of this type, you can always replace it by an equation of this type. So practice this enough so that you can go from here to here, here to here, and very easily, and that move is justified by the cross multiplication algorithm. Thank you.